So you can see the question on the screen. This question is saying, explain equilibrium super elevation, design the rate of super elevation for a horizontal highway curve of radius 500 meter and design speed 100 kmph. So in this question, what we have to do, we have to first of all define what do you mean by equilibrium super elevation. So you can see the definition of equilibrium super elevation on the screen, that it is the traverse slope which is obtained by raising the outer edge of the pavement with respect to the inner edge in such a manner that the pressure on the inner wheel becomes equal to the pressure on the outer wheel. So that is what your equilibrium super elevation means. That means in order to make the pressure on both the wheel, that is on the inner side, inner wheel, as well as the pressure on the outer wheel, when the pressure on both the wheel becomes equal, that particular super elevation is actually termed as the equilibrium super elevation. Okay, so that is the meaning of that. You can write that definition. Now coming to the second part of the problem, they are asking like we have to find the design rate of super elevation according to the given information. So I can write here the given term first of all. Remember, whenever this kind of question comes, the thing first you will do is that you will write down the given information first thing. Okay. So in this question, the given information, if you see the given information in this question, it is first of all they have given you the radius of the horizontal curve. So I can write here radius of horizontal curve is given to you, horizontal curve, that is your R. So this is given to you as 500 meter, and the second one they have given you is the design speed. Design speed, that is nothing but your V. So this is given to you as 100 kmph. So these are the two informations that are given to you, and they have asked you to find the design rate of super elevation. Remember, it's a design rate of super elevation. So whenever design rate of super elevation asks, you have to go via the steps that has been laid out by IRC. So I can write here as per IRC, okay. So I can write here step 1, considering 75% of design speed and neglecting F, that is coefficient of friction, coefficient of lateral friction, lateral friction. Now what I can write, E is equal to 0.75 V whole square divided by GR. You can use the other one also, E equal to V square upon 225 R is the same thing. Okay. So I am writing here that I am considering 75% of the design speed and I am neglecting the coefficient of lateral friction as per the first step that has been laid out by IRC. So I have to put the data in this particular equation, right? But before that, remember that here when you put V, your V has to be in meter per second. So I have to convert this V in meter per second. So for that I can multiply this with 5 upon 18. This will give you 27.77 meter per second. So I can put the values here. E is equal to 0.75 into V. V is equal to 27.77 whole square upon G is 9.81 multiplied by your R is 500. So if you solve this, you will get the value of E. So let's solve it and see what is the value of E. So if I solve this one, 0.75 into 27.77 square divided by G. So this gives a value of 0.088. Okay, this gives a value of 0.088. Now here you see this value is greater than IRC recommended value. And which value I am considering here? I am considering 0.07. Now you might be thinking why I have considered 0.07, because no information is given regarding the terrain. They haven't given you any information regarding the terrain, like what kind of terrain you are considering. So whenever it is not mentioned, you will always consider the plain terrain, as because you can see from the design speed also, design speed is also 100, and generally for plain terrain, the design speed or rolling terrain, the design speed is considered to be as 100 kmph. So because of this, I have considered this one, this maximum value of super elevation as 0.07. So since this value is exceeding this range, what I have to do? I have to go to step 2. So I can write step 2. Step 2. So I can write here, considering full design speed and maximum value of E, maximum value of super elevation, that is E equal to 0.07, the maximum value I am considering. Okay, that is specifically recommended by IRC. So what I can write? I can write F equal to V square, F equal to V square by GR minus 0.07. This is the equation that will be used. Okay, so I can put the values for V and other, and I can see whether this is in limiting range or not. So I can put V as 27.77, G as 9.81, and R as your 500 minus 0.07. So if you solve this, I can find from here what will be the value of F. Let's see. So if I solve this one, 27.77 square divided by G into R minus 0.088, sorry, 0.07, not 88. So this gives a value of 0.872. 0.0872. Now this is less than the limiting value. Okay, limiting value as per IRC. And what is the limiting value? It is 0.15. So we are okay with it. Okay, so we are okay. So I can write the final conclusion here that my design rate of super elevation will be, let me read another pen, design rate of super elevation will be, super elevation, that is E will be equal to 0.07. So this is your final answer. Correct? So this is how the problem can be solved. Okay, so you can write these things.